Hello there. In this lesson, we continue our study of the Introduction to Vectors topic. In particular, we will define and use a variety of notations and representations for vectors in two dimensions. The purpose of the content from this lesson, that is, having designated notations and forms for vectors, is to be able to differentiate between a vector quantity and a scalar quantity. This assists in all the areas using vectors which I mentioned in the previous lesson. In this lesson, we overview the different notations, representations, and forms of vectors, and then we learn how to calculate the x and y values of a vector given its start and finish point. This lesson is a 2 out of 10 for difficulty. The first subpoint will be to use standard notations for vectors. The syllabus outlines 3 such notations. It is important to be able to use and recognize these forms because it is a key component of the fluency and communication of working, which is emphasized in the syllabus. There are a few different ways to indicate that something is a vector. The first notation from the syllabus is A with a squiggly line below it. This line is called a tilde. The second form would be to have AB with an arrow on top of it, and this arrow is called a vector arrow. The third form is the one you can see here, and that is A in a bold font. Now this is one which cannot easily be written, so instead you will usually find it as questions on typed papers. Note that it doesn't matter which form you use, because they are all applicable in all scenarios. The only important thing to notice is not to mix up your vector forms in the same question. Now that we have defined these 3 standard notations, we can move to the second point. Represent vectors graphically in 2 dimensions as directed line segments. We already touched on this in the last lesson. We said that a vector is used to indicate the position in space of one point relative to another. Since vectors have both a magnitude and a direction, we can decipher the distance and angle between 2 points. For example, if I drew 2 points on the Euclidean plane and labeled them A and B, I can draw a vector line from A to B and label it as, say, AB, one of our 3 forms, which we said before. As you will see soon, we can use the coordinates of A and B to find the x and y values of this vector line, and hence its magnitude and direction. So you will remember from the last lesson, define this as a displacement vector, because its start point is not from the origin. We can very similarly represent position vectors on the Euclidean plane. These are the vectors emanating from the origin. This would be done if I plotted a point M, and we had the origin, and we drew the vector line from the origin to M. We could then label this as M with a tilde. That's our first form of a vector. The third point is to define unit vectors as vectors of magnitude 1, and the standard 2-dimensional perpendicular unit vectors I and j. Unit vectors are used when we just want to show the direction of a vector and ignore its magnitude. They are called unit vectors because they have a magnitude of 1. You can imagine an infinite number of unit vectors all lying on the unit circle. We could have them all here. So they all have a magnitude of 1. But there are 2 special 2-dimensional unit vectors. These are I and j. They respectively represent vectors of magnitude 1 which lie on the positive x and y axes. Since they lie on the axes, these 2 unit vectors are perpendicular to each other. These standard unit vectors allow us to isolate the x and y components of vectors and express them in what is known as a component form. If I draw positive 1 on the x-axis and positive 1 on the y-axis, then we could label these 2 vectors here. The final point for this lesson is to express and use vectors in 2 dimensions in a variety of forms, including component form, ordered pairs, and column vector notation. The syllabus outlines these 3 forms which we can use to express vectors. They all rely on us having both the x and y values of a vector. That is their distance parallel to the x and y axes respectively. We will learn how to calculate this in a moment. The first form is the component form. This form utilizes the aforementioned standard unit vectors. If we let x be the magnitude parallel to the x-axis and y be the magnitude parallel to the y-axis, then the general form of a vector in component form would be xi plus yj. Remember the importance of including these tilde symbols on the I and j unit vectors, because this allows us to recognize the x and y values respectively. The second form is ordered pairs. Using the same variables as before, the standard form for ordered pairs would be x, y, using these angled brackets. Note that I use the angled brackets to differentiate the vector xy from the point xy. The third form is column vector notation. This is similar to the notation of a point, but instead of aligning x and y horizontally, as we've got here, we align them vertically, where we would have the vector v is equal to xy. Now these 3 forms all allow us to illustrate the same thing, just are different methods of doing so. Now that we have identified the 3 forms of vectors in the syllabus, we can move to calculating these x and y values. Let's go to this Euclidean plane here. On this Euclidean plane, let's label 2 points, P and Q. Now let's label their coordinates. Since we are just doing a general solution, we will label them as x1, y1 and x2, y2, since we are just doing a general example. The next thing we want to do is draw the vector line from P to Q. We can call this vector PQ. If we want to calculate the value of the vector PQ, we will subtract the position of P from the position of Q. This logically makes sense because we are showing the position of Q relative to P. Therefore, the vector PQ is equal to, let's put it in column vector notation, x2 minus x1 and y2 minus y1. In the next lesson, we will learn about this in more depth, as well as why it works, when we cover the addition and subtraction of vectors. To summarize what we've done in this lesson, we learned the standard notations of vectors and how to represent them graphically in 2 dimensions. Then we defined what the unit vectors are, in particular the standard 2-dimensional perpendicular unit vectors I and j. This allowed us to define the component, ordered pairs, and column vector notation before learning a general form for the x and y values of a vector. Thank you for watching, and I'll see you next time.